students. So those who have not subscribed my channel, please subscribe my channel and also share my videos. So let us start with the question number 13 and 14 of chapter 12 Electricity, class 10th, CBSE NCERT. So the question number 13 says a hot plate of an electric oven connected to a 220 volts line has two resistance coils A and B, each of 24 ohms resistance, which may be used separately in series or in parallel. So they can be used separately, or they can be used in series, or they can also be used in parallel. Okay. So what are the currents in the three cases? So in the three cases we need to find out the current. So when they are used separately, either the resistance coil A will be used or the resistance coil B will be used. So let us start with the question with the first part, when they are used separately. Okay. So in the first part, when used separately, so both the resistance coil have the value 24 ohm. So in the both the cases, the current will be the same, and the 220 volts line is also the same for both the cases. So the individual current IA will be equal to IB will be equal to V by R. So that will equal to 220 volts upon 24. Okay, and so that will give us a value of 9.166 ampere. Okay. (55 by 6) will give me a value of 9.166 ampere. Okay. So this is the case when both the coils are used separately. Okay, either A will be used or B will be used. Now the second case, let us start with the second case. Second case is the case when the coils are used in series. Okay, so when the coils are used in series, then R equivalent will be RA plus RB. Okay, it will be equal to RA plus RB. So that will be equal to RA is 24 and RB is also 24. Both the resistances are of value 24. So we will be getting over here 48 ohms. So we'll be getting here 48 ohms. So the current when they are parallel will be equal to, when the coils are used in series. So the current when the coils are used in series will be equal to V upon R equivalent. Series. Okay, series. So voltage is 220 upon 48, which will give us 4.58 amperes. Okay, so this is the second case, and the third case is the case when the coils are used in parallel. When the coils are used in parallel. Okay. So when the coils are used in parallel, R equivalent will be equal to RA parallel combination with RB. Okay, so that will give us 1 upon R equivalent parallel resistance will be equal to 1 upon 24 plus 1 upon 24, which will give us 2 upon 24, and it will get cancelled. 2 ones are 2 and 2 12s are 24. So ultimately R equivalent will in the parallel connection will be equal to 12 ohms. Okay, it will be equal to 12 ohms. Now in order to find out the current will be equal to V upon R equivalent parallel connection. So that will be equal to 220 upon 12, which will give us 18.33 amperes. Okay. So whatever the connection was, we found out the values for the current. In the first case, it was asked separately. So in the separately, because the resistance value is the same and the voltage value is also the same, so current will be the same for both the cases. Okay, so in the first part the current is same and it came out to be 9.166 amperes. Then in the second part, the coils were connected in series. So in the series, the resistance get added up directly. So this R equivalent series will be equal to 24 plus 24, which will give us 48 ohms. Then we found out the current for the coils when they are connected in series. Then the third part was when the coils are connected in parallel. So in the parallel, in the parallel connection, the reciprocal of the resistance value is get added up. So R equivalent P will be equal to 1 upon 24 plus 1 upon 24. This 24 is for the RA and this is for the RB. Okay, so then we added it and we found out the value of R equivalent P equivalent, which will be equal to 12 ohms. Then in the next step, we found out the current value, because the current value is being asked for all the three cases. So in this manner, we need to find out the currents. Okay, so now let us move on to the question number 14. The question number 14 says, compare the power used in the 2 ohm resistor in each of the following cases. The first case is a 6 volt battery in series with 1 ohm and 2 ohm resistors. Okay, so here the 6 volt battery is connected with the resistors having the value 1 ohm and 2 ohm. Now we need to find out the power in the 2 ohm resistor. We need to find out the value of the power in the 2 ohm resistor. So let us first draw a circuit, how it looks. It will look something like this. A 6 volt battery is over here. Okay, 6 volt battery. Battery can be AC, battery can be DC. We can also put a DC symbol over here. Okay. And the two resistors are connected in series. The 1 ohm resistor as well as 2 ohm resistor are connected in series over here. Okay, so 1 ohm and 2 ohm. Okay, so R equivalent, we'll be finding out R equivalent. R equivalent will be equal to 1 plus 2. Simply the resistance will be added up, because the series connections resistance are added up directly. Now whatever current will flow from 1 ampere, that much current only will flow through 2 ampere, because in the series connection, the current remains constant. Okay, current is same everywhere. And if the resistance are connected in series, the current will be same in all over the circuit throughout. It will be same across the 6 volt battery. Okay, so we have found out the value of equivalent resistance. Now we know, according to the Ohm's law, V is equals to IR. V is equals to IR. So here, from here we can find out I is equals to V upon R equivalent. Okay, so V is given to us 6 upon R equivalent is 3. So we have got 2 amperes as current. Okay, so the current which is flowing through this circuit is 2 amperes. It is equal to 2 amperes. Now we need to find out the power. So we know that the power is given by I square R. It is given by I square R. Okay, the formula of power is equal to I square R. So we will be putting the value over here. P will be equal to I square. I square will be equal to 2 square. And since we are asked to find out in 2 ohm resistor, in this 2 ohm resistor, okay, So we need to find out the power in this 2 ohm resistor. So we'll be putting the value of 2 over here. So this will give us 8 watts as our answer. Okay, so now we will be moving towards the second part. So in the second part, it is given as 4 volts battery in parallel with 12 ohm and 2 ohm. So a 12 ohm is there and 2 ohm is connected up in parallel. Okay, they are connected in parallel, and a battery of 4 volts is connected, Okay, so now we need to find out the power in this 2 ohm resistor. So what we will be doing, we will be finding out the R equivalent first. Okay, we will be finding out the R equivalent first. R equivalent will be equal to 12 ohm parallel to 2, which will be equal to 1 upon 12 plus 1 upon 2 is equals to 1 upon Rp. So 1 upon Rp will be equal to 12, 1 plus 3. 6. So Rp will be equal to 12 by 7. Now, here a point to be noted is that these are parallel connections. So in the parallel connection, the current gets divided, but the voltage across both of the resistors will be same. The voltage remains constant. So let us write down this point. In parallel connections, voltage remains constant. Okay, voltage remains constant. So we can easily find out the power by the formula power P is equals to V square by R. Since we were asked to find out the power across 2 ohm resistor, so we need not to find Rp equivalent also. Okay, if it would be asked in the question to find out the power against the whole combination, so then we need to put the value of Rp. But in this question, we need to directly put the value of R, which is equal to 2 over here. Okay, and we have been already given us as 2. V is given as 4 volts. Sorry, over here V is being already given to us as 4 volts. So 4 into 4 upon 2. So 2 and the 2 is a 4. Again, my value of power comes out to be 8 watts as my answer. Okay, so in this manner we need to proceed the rest of the questions. In this manner we need to proceed the rest of the questions. In the next session, in the next lecture, we will be solving more of the questions of this chapter, more of the numericals of this chapter. So till then, thank you. Please subscribe my channel, please share my videos, and if you have any doubt you can ask me in the comment section. Thank you.